In this class, I'll provide another short demonstration of what can be done with the programming languages that we will learn during this semester. In particular, the focus is on Python, and I want to give a more concrete sense of the degree of productivity that one can achieve, and in particular how to achieve a kind of a non-trivial task with a fairly short piece of code. And as you will see later in the semester, trying to accomplish the same task in C++ would be way more complicated. Just look at something that most people are aware of. I'm going to look at COVID-19 data. The raw data is actually easily available now on the web. And the question is, can we make direct comparisons among a few countries? And I just picked obviously the US just because that's where we live. Italy, it's actually my country of origin, and Belgium is actually among the countries that are not super small. It's actually been hit the hardest by the COVID pandemic. And now I'm gonna just compare what we get directly from the data available on the web, and what one will need to do, for example, as an engineer, if he wants to do some serious comparison of different aspects. In particular, I'll start from the concept also of flattening the curve that was very popular early on. Now people don't talk about very much, but just to have something that is fairly obvious. And there was a lot of discussion about the curve being very high and then going down versus being slow, maybe protracted over time. And this blue curve would be better than the red one because of not overwhelming the healthcare system and so on. Obviously, one would need to know where the red line is, and really it's hard to tell. But as a general guide in looking at how we can analyze the data, and in particular how we get the data in a format that we can analyze, and then simple tools like matplotlib can be used to do plots that are kind of scientifically consistent. So this is a website, worldometers.info, that has a lot of COVID information. In particular, they give you a summary of the number of cases and deaths throughout the world, some summary plots of what's happening in terms of cases and deaths now, and some tables with how different nations are faring. And here is the table sorted by deaths per million of population. This is the column you see that goes from large to small. It's probably not worthwhile considering countries that have less than 100 deaths total, and that's why I was saying that Belgium is the country that's been hit the most. And here is kind of the current ranking: Belgium, Peru, and going down we found Italy, USA, and so on. And so the question is, can we do a direct comparison and see, for example, how those countries compare with respect to this concept, and can we do it ourselves? In particular, if we go inside the website, we found this type of plots of daily deaths for each country, and it's hard to tell, right? Those are different scales and so on, so it's not really something that it's easy to manage. So the idea is to kind of go to the website. So this is the actual website. Here we see the summary information, and then for each country, for example, Italy, so we can go in and look at the plots with the summary information. And what's interesting is that we can actually look at the source code of the page. So this is HTML, and one does not really need to know HTML per se, but you can go through and realize that, for example, all the data regarding the various plot is actually here. So here, for example, you see that there is a table, cumulative deaths. Here, those are the elements, and those are actually the values that we see used in the plots. And so one can look at the various elements in the table and figure out, so here's the table, for example, total coronavirus deaths, and this is the table day by day and so on, corresponding, for example, to this number of cases. So it's a great opportunity to harvest in this data, and once we have the data, then, for example, we can normalize it by the number of the size of the population and the rate over time, and make plots that can actually be more interesting from an engineering point of view. So this is the piece of code that I wrote for this purpose. As you can see, it's actually fairly short. Again, here we are early in the semester, so I don't expect people to follow in detail. And in fact, actually, we hope later on to come back to this and maybe do this as a homework, as an exercise of some kind. We import a few library. Matplotlib, for example, is the main one for doing the drawing. There is a library to parse HTML. There is a scientific Python library to smooth the plots so that we don't have artifacts of various types and so on. Here, I'm making the list of the nations I'm interested in. So what's nice is that I could use this code to actually compare more and more countries, not just 3. But for now, that's kind of what I'm doing, just to make the plots not too busy. And then we define a simple function like this that goes to the URL of the country and of the worldometer, and add the name of the country. So if you can see, the URL here says worldometer coronavirus country Italy. But if I go to the US, for example, then the URL will be worldometer country US, and this one, it will have more detail, but still we get a similar daily deaths information that we can go in and look at the source and scrape the data directly ourselves. So here, for example, we open the source, and here we have, this is the x-axis, and this is the actual value of the table that we're trying to retrieve. This is for Italy, this is for the US, same thing for Belgium. So here we have the opportunity to go and scrape the data. It's actually a very simple function. We go through the lines of code, we search for the word, the keywords daily deaths, and then we go into the categories, and then finally we look for data, and as you can see here, that's what data, and then we start reading the numbers from the open parentheses to the end. So with a simple piece of code like that, we can go on the web, parse the information from the source, and then look at the data entirely and add the information we want. So here we have this simple loop for I, so going through the name of the nations, and then we just call this function one by one so that we can read the data. Once we have this, we can do some simple massaging. It's kind of, for example, renormalized by the size of the population. So for each country, we have the name as a website, the actual name with proper capitals and so on. And then we have the size of the population that we can use this later in the plot. So I'm going to do 2 plots, one with the daily deaths properly normalized, and then with the cumulative one. The first one, well, I'll draw it incrementally. And so we will see preparing the data, and In particular with sci-fi, we'll smooth the plot a little bit so that we don't see the artifacts that we see here in the reporting. You see how this goes up and down. This is actually interesting, is the weekly cycle. During the weekend there is always fewer reporting, and so we smooth that away so that we don't get information that is unrelated. And so in the first plot, I'll draw all the data, and for every nation I'll kind of wait until I press the space bar so that we can see one at a time. In the second plot, I'll just plot everything directly in one plot. There is no waiting. So sorry, this is the component. We draw everything without any waiting. And so this is kind of give a sense of, with a very small piece of code, we can accomplish a fairly complex process. So I'm just running the code right now. I had a bunch of prints to debug the process. And so here you see the first plot of the daily deaths. And so here in March there was a big rise and then going down for Belgium, for the country of Belgium. And after that we can plot the trends for Italy. So we can see now this second plot coming in. This is Italy. Interesting, Italy was actually hit earlier. It goes up and actually compared to Belgium was able to flatten the curve more. And then a crossover, had a little, for a while it was above, and then it actually had fewer cases again. And then finally the US, which actually flattened the curve by comparison even further. Again, in this axis is daily deaths per million of population. Obviously the total number of deaths in the US was kind of much higher. And so this kind of compared the three curves. And then we can see the comparison with the complete community curves. And so we see how Italy started earlier. Belgium had this big spike and so crossed over and get more cases. And now it's entirely almost flat. Actually, it has a little increase now. Italy had the big spikes and now it's entirely flat, while the US keep growing and growing. And unless it flattens even more, it may cross over and surpass Italy. So again, this is not about COVID, but just to give a sense that this is the type of analysis that with engineering data you will have to do over and over in your career. And so while C++ would be good for heavy data processing, Python can be very good for quickly accessing data sets and creating plots that can give interesting results and that can be modified on the fly. I hope this was kind of interesting and provide good information regarding the use of Python. And again, at the end of the semester, if we have time and the students are interested, I may go through this example or something similar just to show how to use the different libraries. Thank you.